Okay, linearity and undetermined coefficients. So introduce what linearity is, particular solutions and homogeneous solutions. We talked a little bit about that in the integrating factors thing, but we didn't call it by that. And then we'll talk about undetermined coefficients and guidelines about guessing. Undetermined coefficients is also well, it's guessing, but it's informed guessing. So a little thing about linearity, particular solutions and homogeneous solutions. If this is our first order linear equation, the associated homogeneous equation has the right-hand side equal to 0. And so we have a couple of properties of this. If we have a solution to the system, if we have solutions to the homogeneous equation, y1 and y2, then if I take any combination of y1 and y2 where multiplied by various coefficients, then I also get a solution. So I should have labeled these 1 and 2. So part 1, the homogeneous equation is dy dt plus p of ty equals 0. Homogeneous generally means that the right-hand side is equal to 0. Now, y1 of t is a solution means what? Well, it means that if you plug it in, you get something true. So in this case, what it means is that dy1 dt plus p of ty1 equals 0, right? It's a solution. That means if I plug y1 into this equation and I plug it into the left side, I get 0 out. It satisfies the equation. y2 of t is a solution also means that dy dt, the first derivative of y2 plus p of ty2 equals 0. Great. So how do I check that something's a solution to an equation? You plug it in and see that it works. So if I know that these two things are solutions, is ay1 plus by2 also a solution, where a and b can be any constants? So how do we check and see if that's a solution? Well, we plug it in. Derivative of our thing that we want to be a solution plus p of t times the thing that we want to be a solution equals, with a big question mark, 0. If it is actually 0, then it's a solution. If it's not 0, then it's not a solution. So we calculate the left-hand side. So derivative of two things added together is the derivative of each, and we know that you can factor a constant out of a derivative. So this becomes this. Great. So what am I going to do with that? I am going to gather all my terms with an a together. Oh, we'll have my big question mark equals 0. A dy1 dt plus p of t y1. So that's this term has an a in it and that term has an a in it, plus b times dy2 dt plus p of t y sub 2. That's this term and this term. And what does that actually equal? Well, we hope that equals 0, but what do we know about dy1 dt plus p of t y1? y1 is a solution, so that means this equals 0. So this is a times 0. y2 is a solution, so all of this equals 0. That, of course, equals 0. Is that equal to 0? Yes. So if I have two solutions to the homogeneous equation, I can multiply whatever constants I want, add them together, and I get another solution. Excellent. So suppose I have two solutions to the non-homogeneous solution then equation. That means I've got a Q of t that might not be equal to 0. Well, we know about any two solutions to a non-homogeneous equation. What that means is that the difference solves the homogeneous equation. So same procedure here. Y1 solves y prime plus py equals q, right? And here y is a variable. So what this means is that y1 prime plus py1 equals q. Likewise, since y2 is a solution, that means if I plug it into the non-homogeneous equation, it works. And so y2 prime plus p y2 is q. So does y2 minus y1 solve y prime plus py equals 0, which is the homogeneous equation? Well, plug it in. The left-hand side, we plug in y2 minus y1 in for y here. So we get d by dt y2 minus y1 plus p times y2, oops, no, that's right, p times y2 minus y1. So that's what I get when I plug in y2 minus y1 for y here and here. But that's dy2 dt plus py2 minus dy1 dt minus py1. Right, so that's this term and this term, my two y2 terms, this term and this term, my two y1 terms. What does this equal? Well, it's dy2 dt plus p y2 minus the quantity dy1 dt minus p plus py1, because I'm factoring out that minus sign. Great. What is this equal to? Well, this part equals q. That's this equation. This part in the parentheses here equals q. The whole thing equals 0, which is my right-hand side of my equation. And that's supposed to stand for right-hand side. So, great. What does that tell me? That tells me that the difference of two solutions to the non-homogeneous equation is a solution to the homogeneous equation. So this tells us something. If y of t is a solution to this equation, right, then y of t is going to be some particular solution plus a solution to the homogeneous equation, right? The yp of t is that. And we've seen that for the integrating factors a lot, because whenever we did the integrating factors, this was a particular function. And then this was the c over mu term, which involved the arbitrary constant c. Okay, so solutions to linear first order equations have a particular solution and a homogeneous solution, and that allows us, we can use careful guessing, and we don't have to use integrating factor. So here's dy dt equals 7y plus t by using a careful guess. So the homogeneous, we'll rewrite it like this: minus 7y equals 0 equals t. Homogeneous equation is the right-hand side equal to 0. This is not too hard to solve because it's actually separable. If we go back to dy dt equals 7y, then this becomes dy over 7, dy over y equals 7 dt, which means log of y after we integrate both sides equals 7t plus c. So y equals e to the 7t plus c, which is k e to the 7t. And that's actually the first problem that we did with integrating factors. We get this. So a homogeneous solution is ke to the 7t. So we just need to find a particular solution. And by particular solution, we mean any solution that works in this equation. So how do we go about doing that? Well, this is a line. So we'll guess a function of the same type. That's y sub p for particular solution equals mt plus b. That's the classic equation of the line. And the question is, what are m and b? Okay, so if this is a solution, if a solution so if it's a solution, it should work in the equation, which means we plug it in and we see what we can get for m and t. So plug in to this equation, and what do we get? We get the derivative of mt plus b minus 7 times mt plus b equals t. Do the differentiation. The derivative of a line is just its slope, so that's just going to be m minus 7mt minus 7b equals t. Great. So we gather everything together. We'll add a 7mt to both sides, and that will give me 7mt plus t, and add a plus 7b. And a minus m 0. So I moved all of this stuff over to this side, so it's on the same side as the t, and then I flipped it, so everything's on the left side. In any case, we get this. So what does that tell me? That tells me that if this is function is equal to 0, what that means is that this coefficient has to be 0, and that coefficient also has to be 0, because it's got to be 0 for every single t you plug in, and the only way you can do that is have the coefficients equal to 0. So that tells me that m has to be minus 1 over 7. Great, that tells me that 7b plus 1 over 7 has to equal 0 once I plug this minus 1 over 7 in for m there, or b has to be minus 1 over 40. So the general solution to this equation is the particular solution plus the homogeneous solution, and that's going to be minus 1 over 7t, because that's what m is, minus 1 over 49, plus ke to the 7t, because that's our homogeneous solution, which is up here. Great, and so if you go back and check on the integrating factors, your notes from the integrating factors lecture, this is exactly the same solution that we got, but I don't have to do any integration. So solve dy dt equals 7y plus cosine t by using a careful guess. So step 1, find y sub h. And that means just looking at this equation. Dy dt equals 7y, and we know what the solution to that is. It's ke to the 7t. In general, anything, if I have a constant here, y is going to be ke to whatever this constant is times t. Useful just to know that. Cosine t, as you know from calculus, is always connected to sine t. So if we ever have a cosine t on the right-hand side or a sine t, we always guess a cosine t plus b sine t. And if this had been a cosine 3t, your guess would be a cosine 3t plus b sine 3t. You want to make sure that you match whatever's inside of your cosine. So what's the derivative of that? Derivative of cosine is minus sine. Derivative of sine is cosine. So to find out what a and b are, those are undetermined coefficients, we just plug this into this whole equation. So that gives me y, the derivative of yp on the left-hand side. So that's minus a sine t plus b cosine t equals 7 times yp on the right side, 7 times a cosine t plus 7b sine t plus another cosine t for my q of t. Great, so we plugged everything in. Now we gather like terms together. So we'll gather all of our cosine terms together and all of our sine terms together. So I've got a minus a sine t. I've got a 7b sine t. So I'm going to move everything over to the right side. And I've got 7b sine t plus an a sine t. That's these two terms. And then plus I've got a 7a and a 1 and a minus b times cosine t. Great. So what does that tell me? Well, if 0 is equal to something involving sine t and cosine t, and that means that no matter what t I pick, this has to be true. So what that means is that this coefficient has to be 0, and this coefficient has to be 0. Great, so what does that tell me? That tells me that a equals minus 7b, that's this equation, and also that (7a plus 1) equals b. So I can combine these two equations. I'm going to just plug in minus 7b for a, and I get minus 49a plus 1. You minus 49b plus 1 equals b. So minus 7b in for a, that gives me minus 49b plus 1 equals b. Adding 49b to both sides tells me that b equals 1 over 50. And then that tells me that a equals minus 7 over 50. And you can plug that in so that our particular solution becomes, well, let's do this over here. So the solution that we get, y of t, is minus 7 over 50. That's a, and a is times cosine t, plus 1 over 50 times sine t. That's our particular solution. Plus the homogeneous solution, k equals 7t. Why this is better than integrating factors? Because integrating factors, if you do this, your integrating factor will be e to the minus 7t, and then you have to integrate e to the minus 7t times cosine t, which, if you remember doing that in integration by parts in calculus 2, is kind of a pain. So we wouldn't want to do that. So what about this one? Same deal. Find the homogeneous solution first. That means solving this equation, and we've done that a couple times. It's ke to the 7t. What's the guess? If we have an exponential, we want to guess another exponential. So guess y sub p of t equals a e to the 4t. And again, we want to match what's in the exponent there. So what's the derivative? It's 4a e to the 4t. To find a, we plug in. So dy dt is 4a e to the 4t. That's this term, plus 7 equals 7 times our guess, which is a e to the 4t, plus an e to the 4t. All my e to the 4t's cancel out. I'm left with 4a equals 7a plus 1. Subtract a 1 from both sides, subtract a 4a from both sides. A equals minus 1/3. So our solution is minus 1/3 e to the 4t plus k e to the 7t. Our particular solution plus our homogeneous solution. So solve this by using a careful guess. Okay, I'm not actually going to go through this one in detail. Our homogeneous solution is going to be k e to the 7t. What's the guess that we use? Well, this is a quadratic. So it's a quadratic plus exponential. So my guess is I'm going to guess a quadratic, something squared, to deal with this term. And then I'm going to guess an exponential to deal with that term. And I'm just going to add them together. So a quadratic is at squared plus bt plus c. And you have to remember to keep all of these terms in your quadratic, because once you differentiate it, you're going to lose the t squared term, right? It'll become a t term. And so you're going to need a bt to help you out with that. Plus d times e to the t. So I guess maybe we'll do this. If we plug this in, left-hand side is the derivative. That's 2at plus b. Right-hand side is 7 times this, 7at squared plus 7bt plus c plus 7 on the c plus 7d e to the t plus t squared. Great. So what's our equation then? We've got t times 2a Oh, I forgot my d e to the t. So when I differentiate this, I get 2at plus b plus d e to the t, got to differentiate that. Multiply this whole thing by 7, and I also have an e to the t out there at the end. I'd forgotten all the e to the t's. So I have a t times 2a plus a constant b plus d times e to the t. And that's equal to t squared times 7a plus 1, 7a plus 1, plus t times 7b plus 7c plus an e to the t times 7d plus 1. So this is secretly also 0t squared right out the front. So we have to be able to match coefficients. We get 7a plus 1 equals 0. The coefficients of t have to be the same. So that gives me b 7b equals 2a. So this 7b has to be equal to 2a. The constants have to be the same. So that tells me that b equals 7c. And finally, the e to the t coefficients have to be the same. B equals 7d plus 1. And so you can solve all those, right? From here, you figure out what A is. Once you know A, you can figure out B. Once you know B, you can figure out C, and you can figure out D from that and plug everything in. So if we got two different things on the right-hand side, make a guess for each one, and then you can figure out what the particular solution is. This one is a little bit trickier though, although it doesn't look like it at first. What's our homogeneous solution? y sub h of t is k e to the 7t. Again, that's just solving this, and you can do that by separation of variables. We did it in the first thing. What would be our guess? Well, if we have an exponential, we want to guess an exponential of the same form. But there's a problem. This is the homogeneous solution. So what I know is going to happen if I plug this in, these two terms will cancel each other out, and I'll be left with an e to the 7t. This won't actually turn out to be a solution to this equation. So check. The derivative of yp of t is equal to 7a e to the 7t. That's the left-hand side. The right-hand side is 7a e to the 7t. If I plug my guess in for the y here, plus e to the 7t. So we're sad and unhappy because they're not equal. That's not a solution. So you have to be careful. If your guess is the same as the homogeneous solution, there's a problem. So how do we deal with this problem? Well, the product rule comes to us. The product rule saves us again. So we're going to change our guess by multiplying by t. And now the derivative of this, we pick up an extra term because it's a product. Derivative of the first is 1, so we get a e to the 7t, plus the derivative of the second times the first. So the derivative of the second is 7, and then I have the at e to the 7t. So now when we plug in, the left-hand side is the derivative, which we just have here, a e to the 7t plus 7at e to the 7t. And the right-hand side is 7 times y, which is 7 times this, plus e to the 7t. If we set left-hand side equal to right-hand side and try and solve for a, what do we get? We get a e to the 7t plus 7at e to the 7t equals 7at e to the 7t, and I haven't had lunch yet, and writing all these 8s is making me hungry, plus e to the 7t. These two terms cancel out, and we're left with e to the 7t equals e to the 7t, or a equals 1. So the solution then here is the homogeneous solution, which is k e to the 7t, plus our particular solution. Homogeneous plus our guess, which is the particular solution. And this was k e to the 7t plus t e to the 7t. And that gives us our solution to this equation. So you have to be a little bit careful. If your solution matches your homogeneous equation, you have to multiply by t and try again. So guidelines about guessing. If this is our first order linear differential equation, where this is k is a constant, then y sub h of t, our homogeneous solution, is some constant times e to the kt. I shouldn't have used k there, but that's okay. And y sub p of t can be guessed based on the form of this. So you guess the particular solution. If it's a polynomial, guess a polynomial of the same degree, and make sure you include all the powers below it. If it's a sine t plus b cosine t, guess a sine t plus b cosine t. If q of t is e to the mt, guess a e to the mt. If q of t is e to the kt, right? We've got exactly the same thing, right? So if this q of t is actually the solution to the homogeneous equation, multiply by t and try again. So if q of t is the same as solution to the homogeneous equation, multiply by t and try again. And so if you have a sum of various things, right? Polynomial plus sine plus exponential, add them all together and see what you got. If things are multiplied together, or if you have tangents or secants, you probably don't want to go with guessing because those get really complicated and are hard to solve via guessing.